All right, our last video of the Chapter 9 test review. This is page 3, 18 through 20 plus a bonus. All right, number 18. What are the roots of the quadratic equation whose related function is graphed below? All right, so roots are the solution, right? Or the x-intercepts. When they ask you for the roots, that's just another way of saying where does it cross the x-axis. So here's the x-axis. It's always hard to see on these graphs. Okay, so it crosses at 0 and positive 4. Crosses at 0, positive 4. So what are the roots? 0, positive 4. It's just asking you for the x-intercepts. Easy enough. Number 19. Which equation corresponds to the graph shown? Oh, I didn't realize you couldn't see that. Sorry. All right, for this one. So here's our x-axis. Here's our y-axis. This one's a little trickier. First thing I see is that my axis of symmetry is right here, and my vertex is right here. So if I look at these boxes, they're each 3 units in this graph, right? And this vertex is about halfway, so it's about 1.5 is my axis of symmetry when x is 1.5. Right? So one of these equations, when I use negative b over 2a, remember that's my axis of symmetry little formula, one of those has to be close to about positive 1.5, right? So let's start trying them out. Let's do negative 3 over 2 times 1, because this is a is 1. Negative 3 over 2 times 1 is going to be negative 1.5. That's not what we want, so that one's out. Or wait, is it? Oh, no, sorry, my fault. Sorry. It's negative 3 over 2 times 1, right? So then that becomes positive 3 over 2, which is 1.5. That's exactly what we want. That was the answer. This is what we want. Sorry, I jumped the gun again. This is the one we want, okay? This one wouldn't work because it's going to be negative 1.5. This one wouldn't work because it would be negative 7 over 2, which would be negative 3.5. And this one wouldn't work because it would be positive 11 over 2, which would be 5.5, right? And we can't go over 5.5. Our axis of symmetry is over 1.5. So the only one that fits that is this first guy here, A. Also, negative 12, when we plug in 1.5 for x, right, what is our vertex going to be at? What's y going to be? It should be down here like it looks like negative 12 or maybe a little bit lower. So if I take that equation, y equals x squared minus 3x minus 12, and I plug in 1.5, y equals 1.5 squared minus 3 times 1.5 minus 12. 1.5 squared is 2.25, I believe. Yep. 2.25 minus, that's 4.5 minus 12. 2.25 minus 4.5 minus 12 equals about negative 14.25. And that's a little lower than what this graph looks like. The graph only goes down to about 12, but remember that these lines are also 3 units each, right? It does look like it should come down a little lower, but this is our none of the rest of these work as far as where the axis of symmetry is, so that we're just going to have to go with that one. It's the closest, right? It looks like the vertex is down here, negative 12 or just below. The actual vertex should be at negative 14.25. So we're going to say that's close enough, and we're going to go with A. Okay, and then the last one here, number 20. Let me back up again. Number 20 says, consider the equation, this guy right here. Determine whether its function has a maximum or minimum. Okay, well, the number in front of x squared is positive, so it opens up. So the vertex is going to have a minimum. It's going to be at the bottom. So we know it's going to be a minimum. So we can go ahead and rule out our choices that say maximum. And then state the maximum or minimum value and what are the domain and range of the function. So we have to state the vertex. If the vertex of this equation is the maximum or minimum, it's saying, well, then what is it, right? So to find the x value of the vertex, I use negative b over 2a, and then whatever that is, I plug it back into my equation to find y. So I'm going to use negative 5 over 2 times 1. That's negative 5 over 2, which is about negative 2.5, or 2.5. Right, so that's my x value, negative 2.5. And then when I plug it back in here, 2.5 squared is 6.25 plus 5 times negative 2.5, 5 is negative 12.5, so it's not going to be plus, it's going to be minus 12.5, and then minus 6 on the end. So when I simplify that, let's see, do it over here. 6.25 minus 12.5 minus 6 equals negative 12.25. Negative 12.25. So our vertex, our minimum, should be at negative 2.5, negative 12.25. Right, so it's this guy, C. Yep. Uh-oh, I'm blurry. Okay, there. All right, I kind of ran through that really quickly. All we had to do is figure out, does it have a minimum or maximum? It's talking about the vertex. So you just look at the number in front of x squared. If it's positive, then our parabola opens up and the vertex is the lowest point or a minimum. If it's negative, the number in front of x squared, then our parabola opens down and the vertex is the highest point or a maximum. In this case, it's positive, opens up, we have a minimum, so we ruled out the 2 maximum choices here. So we were left with these 2. Then it asks, where is that minimum or maximum value? So in other words, what is the vertex? So we use negative b over 2a to find x, and then we plug that back into our equation for x and solve for y, and we got this guy. Okay, number 21. What is the equation of the axis of symmetry of a parabola if its x-intercepts are negative 3 and 5? Okay, so if the x-intercepts are negative 3 and 5, that means the solutions are negative 3 and 5, right? So how else could I write that? Well, remember when I'm solving a quadratic equation, I factor it to get down to this point, set equal to 0, I set each parentheses equal to 0, and I solve for x. So in this case, one of them's equal to negative 3. So that means the original binomial here would have had to be x plus 3. Because if x plus 3 equals 0, and I subtract 3 from both sides, x would equal negative 3, right? Same thing here. This is positive 5, so that means this would have had to be x minus 5. Because when I set this equal to 0 to solve for x, I would add 5 to both sides and x would equal 5. So if these are my solutions, these must have been the 2 binomials that I had set equal to 0. So then I can go ahead and FOIL method or whatever, multiply this out and get my original trinomial equation, right? So that's x squared minus 5x plus 3x minus 15. When I simplify that, I get x squared minus 2x minus 15. Okay, so then my a value is 1, my b value is negative 2, and my c value is negative 15. The question is, what's the axis of symmetry, right? The axis of symmetry equation is negative b over 2a. So my b value is negative 2, negative 2. Over 2a, a is 1. So when I simplify this, it's going to be positive 2 over 2, which is just 1. Okay? So there's not really an equation. If they asked you for the equation, I guess this would be the original. There's no variables left because we have everything we need to plug in. So you would write this down, and then you would show me how you simplified down to just one numeric answer. Right, so where is the axis of symmetry? That's what it's asking. It's at x equals 1. The axis of symmetry is at 1 based on the fact that the parabola crosses the x-axis at these two guys. That's a really hard thing to think of. Like, I don't know where the axis of symmetry, I don't even know what that is, right? Based on this number, this is all gibberish to me. But just take what you know. X-intercepts are solutions to a quadratic, right? When we solve, we set each binomial equal to 0. If we did that, the result is -3 and -5. So let's work backwards and see where we had to have started. If this is where we started, then I can multiply that and create my trinomial. Once I have my trinomial and I know A, B, and C, then I know what to plug in here. Okay, that was a bonus. That was a tricky one. Let me know if you have any questions, and I am working right now on a little like sort of summary sheet for you guys to use on your test that has all of this kind of squished into 1 or 2 pages. So it's like a quick reference guide. Okay, so let me know if you have questions, and good luck.